Cool. Let me move some stuff over here. Okay, yeah. So just following up on what Caleb was showing with DeltaBit, TerraBit was a similar project where essentially I was low on compute resources. I normally would use like GPUs to do this and vector databases and all that. And I was trying to make something that was like shareable in the browser. And so Legend actually output their Clay embeddings for Sentinel-2 for full 2 years, I believe. And it was about 185 gigabytes, but I wanted to figure out like I think there's a lot of redundancy in the data. There's 1024 dimensions. It's float 32. Do we actually need all that precision and all those dimensions? And Caleb's DeltaBit kind of shows like if you look at the blog, where you only need a few dimensions, and mine is going a different route where let's just be crazy and like completely binarize the embeddings down to they're still 1024 dimensions, but instead of float 32, they're basically binary. And that compresses actually down to about 11 gigabytes total, and it's all GeoParquet. And so essentially, I made um, a little web app. I put it in the link if in the chat. Let me refresh real quick. But the idea is that you can do global, but you could also I my assumption is that a lot of people aren't actually doing global like embedding retrieval. They're wanting to focus on like smaller AOIs, kind of like what Caleb was showing. And so this application is sort of surfacing that implementation. And so the idea is very simple. You draw a box or a polygon around some area you care about, and then you can click some query samples that you care about. And as you click, the GeoParquet like embeddings are getting streamed on the fly from Source Cooperative cloud storage. And then you can also click negative samples. So if you don't care about those, and essentially what it's doing is because it's binary, it actually doesn't need GPU. It uses a very optimized implementation of the pop count algorithm, which is incredibly fast on CPU, and is able to run this pretty well on a lot of different compute. Entirely in your browser, no backend needed. And so there's a lot more features that I added to this, like different view modes. So like if I just click through like a few examples and I want to see like the top K most similar, if I want to just show a heat map, like not just filtering, but show like everything that is most similar to this point in this area, like show it really bright, orange or yellow, and everything is darker. And then you can have like a little cutoff where I can increase that filtering. And then I have a few others that are not actually dependent on any exemplars here. So outliers is like within this AOI, like show me the most dissimilar, like the most unique patches. And then you have surprise, which is patches that based on their surrounding neighbors, like are very dissimilar. And then edge is where you have this boundary where similarity score changes very abruptly. So in this like AOI, this is like the outlier. There's obviously not a lot of like interesting outliers in this little AOI though. But you can just kind of play with it. The nice thing is you can also like export to GeoParquet. So if I click a couple points, I can click export and it'll actually export those with their similarity scores and the bounds of each patch that the embedding came from, along with the embeddings. I also did a bunch of analysis on like the embedding data set itself to try to find very unique samples. So if we just clear here and we go over to, let's just in this discovery section, I have like a bunch of areas that are like I analyzed the embeddings and found that the embeddings are very, very unique compared to the entire like 185 gig data set of embeddings. And so you can just kind of click around. It's pretty fast. And then in this explore section, these are just like known. They weren't analyzed via the embeddings. But we can go over here. Let's see. We'll do the Palm Island since that's pretty popular. So I can just draw a polygon, and then as I've clicked that, it's already streaming the patches. So it's already loaded. I can start looking at different views. I can go over here and let's say I want to detect like the fields here, draw and then put a couple negative points here. You can see it starts to pick up some of these, and then you can just keep refining a bit. And then it starts to pick this up. I can export it. What's really cool is I can actually draw multiple polygons. where like let's say I've picked fields in this area, I can actually go an entirely new area. Um, let's see. I don't know where fields are in the sub-Saharan desert, but okay, here we go. Looks like some large corporate farming going on here. So I can draw another box here and we'll just try to encompass that. And it's loading those patches. And then as soon as those load in, it will already compute the similarity from the other AOI that I was using. And so this takes a little bit of time. You're basically because it's all in browser, you're basically network bound at this point, where you've offset that to not having a backend to only using a front end. And actually, we can just make this a little bit smaller, maybe for time. While that's fetching, we actually had a blog post about it, where I did some more analysis. If you're interested in like the compressions, I used binarization, but I also did a bunch of analysis on like Google's turbo quant algorithm, which gets you some better results. Some analysis on like what the reconstruction results are if I, do the quantization and then reconstruct it back. We do a bunch of intrinsic dimension analysis too. Intrinsic dimension is the idea that like if I have 1024 dimensions, like what are the minimum number of dimensions I need that keep the maximum amount of signal. And so that's about 13 to 17 for the clay embeddings.